All right, good morning. Lesson 11.8, which is our second to last lesson in this unit, but it is the last lesson on graphing. So what we're going to do is we're going to turn it into a little bit of real life models that actually are not as corny as you think. They do exist in real life. Um, let's see what we got here. You do need your calculator. If you have it, that makes your life a lot easier. We are going to compare some stuff on the calculator to the pictures that we draw. So we have two models for sinusoidal modeling. It depends on what you're trying to model. You can either use a sine curve or you can use a cos curve. They will lead you through it for the most part. So just a couple of things, a little bit of reminders. We have an A, a B, and a C. So when we're talking about graphing, again, the absolute value of A, right? We know that that's the amplitude. And we also know that that's the distance from the midline. Right? So in our approach from graphing, we would graph our midline and then count off of that by this A value. All right, the C value, which is the value at the end, that is your midline. Okay. B value, that's your frequency. And that tells you how many complete cycles. You'll see if you graph from 0 to 2 pi. All right, the period uses the frequency. It's 2 pi divided by B, and that's the length of one cycle. Okay. When we are setting up our graph, we look at the x scale. The x scale, you take the period that you found and you divide by 4. Okay. So a couple of formulas. If you guys remember, I'm going to write them up over here. To find A when you don't have a graph, you're going to take the max minus the min all over 2. Actually, you use that when you have a graph. I stand corrected. When you don't have a formula, that's how you figure out what your values are. Your C value, that's the next one. The midline, that's the max plus the min over 2. So we talked about those formulas. So to find your A value off of a graph, max minus the min over 2. To find your C value, max plus the min over 2. All right, so let's kind of put this all together in a question here. We have the tides in a particular bay can be modeled with an equation. It's in the cos form, right? There's an A, a B, and a C. T represents the number of hours since high tide. D represents the depth of the water in the bay. The maximum depth of the water is 36 feet. The minimum depth is 22 feet. High tide hits every 12 hours. All right, so actually that's enough information to actually set up the graph and also to write the equation. So a couple of things, right? High tide, 36 feet. Low tide is 22 feet. So these are really, really important numbers on our graph, right? We have a 36 and we have a 22. We know that high tide hits every 12 hours. So you're going to start with a cos curve. Remember, cos starts at the height or the max, right? And it's going to start at the maximum and it's going to go down and then it's going to up back to the maximum. That's every 12 hours. So in a 24-hour period, you're going to hit high tide twice. All right, so we got to figure out our values of A, B, and C, and then we're going to sketch. So remember, A is your max minus your min. Your max is 36 minus your min of 22 over 2. 36 minus 22 over 2, that's 14 over 2, which is 7. All right, your C value is the same values just added. 36 plus 22 over 2, which is going to give you, what's that, 58 divided by 2 is 29. So remember, that 29 is our midline, right? So that 29 is right here. Okay. The B value. All right, you're going to get the B value from the period. Okay, so I'm going to do that work here. To get B, right, we take our formula, 2 pi over B for the period. They told us high tide is every 12 hours. So this period formula, right, the length of the high tide is 12. Put that 12 over 1, cross multiply. 12B equals 2 pi. Divide by 12. And reduce. Pi over 6 is your B value. Okay, so a couple of things. I know I'm going to hit high tide twice, okay? Twice in 24 hours. I think they want us to graph it for graph it for 2 full periods. You know why? 12 hours for 1 period, another 12 hours for 2 period. We're going to graph it over the course of a day. So now remember, the period divided by 4, right? So we take our period, which is 12, we're going to divide by 4. So we space by 12 divided by 4. So every 3 increments, okay, or every 3 hours. So we have 3, 6, 9, 12. All right, 1 complete tidal period. Okay, 3 more would be 15, 18, 21, 24. All right, so I've got 1 cycle here, the next cycle here. I know I'm going to fluctuate between a high tide of 36, low tide of 22. It's a coast curve, so it's going to start high at 36. And remember, when you graph the coast curve, right, it goes max, midline or 0, minimum, back up to the midline, back up to the max, midline, min, midline, max. That's actually a little higher than I wanted to. All right, so that is actually your coast curve. Okay, that depicts this situation. So we are going to verify with the calculator because we actually want to use the calculator to solve our next part because it's a little bit annoying. It says tanker boats cannot be in the bay when the depth of the water is less than or equal to 25 feet. If it's less than or equal to 25 feet, that tanker's going to run aground. So that's no good. So we have to figure out when can they be in there, during what interval of the tide can they be in the water. All right, so first of all, equal to or less than 25 feet. Well, 22 to 29, that's 7. So we're right around here. So visually, right, your tanker cannot be in there from here to here or here to here. That's bad news. All right, so we're going to hit our calculator up for this. This is interesting. All right, we have to do a couple of things first. You want to check your mode. You want to make sure when you're graphing a trig function, you're in radian mode. Okay, that's the most important thing. If you go to graph and you get a straight line, you don't get a curve, you're probably in degree mode. All right, so there we go. There's our picture. All right, so now first thing we have to do is if we're going to use our calculator, we have to come up for a formula. So our formula, A cos B times T plus C. All right, so in Y1, we're going to plug in our A value of 7, cos, remember our B value was pi over 6, and we have a T, right, because it's a T here. Close your parentheses plus 29. So that's going to be your curve. Now, when the water was 25, that's where we had an issue at those points of intersection. So in Y2, we're going to plug in a 25. Okay. So let's go to our calculator. Let's go to Y equals. I'm going to type in, let's see, 7 cos. I'm going to put this down. Cos, we have a parentheses, so pi, second, nope. Okay, my eyes are horrible. Divided by 6. And then I think I would drop, because I have an older style calculator, I would drop the x, but make sure you have a double parentheses. Okay. And then let's see, plus our C value of 29. Okay, and then I'm going to swing a line at 25. So what I can tell you is that I am on a standard window. So if you hit zoom 6, you're not getting anything. So what I want you to do is I want you to look back at your graph that we drew. Now our X-min was 0, X-max was 24, right? So let's go from like 0 to 25. And then look, we have from 0 to, I don't know, make it go higher than 36, so 0 to 40. So go to your window, 0 to, actually let's just make it to 24. Let's make it an exact match for the X values. Now the Y-min, I'd put 0. I would go a little higher than 36 because you don't want to just see it hit. So I would go, let's go up to 40 there. All right, this should match what we have to the right. There's one cycle, and there's 2. That's beautiful. Now it just swung that line at 25. So what we're interested in this point of intersection and this point of intersection. So from here to here, no good. From here to here, no good. So we have to find 4 points of intersection. So let's see. Second calc, intersect. I'm going to go all the way to the left. All right, I'm going to hit enter, enter, enter. It says round to the nearest tenth. So it looks like the first one is 4.2. All right, so let's find the next one. All right, looks like 7.8. Find the next one. $16.2. Okay, 19.8. All right, so here's the deal. Here's your points of intersection. So tanker can't be in the water from here to here, can't be in the water from here to here. All right, so what we need to do is we need to write up the inequality. Now I'm going to stick with the set builder notation because they did do set builder notation here. You could always put it in interval notation. They say that less than or equal to 25 feet, so it is going to include it. All right, so tanker cannot be in the water from 4.2 hours into the cycle all the way to 7.8 hours in. So remember, when you write up your inequality, low end, high end, we're going to put it's a T in between, point to the left, point to the left. It does include it because it says less than or equal to. So that's your first interval. Your second interval, again, drop your left side, drop your right side. The variable in between, always point to the left. And again, it did say equal to, so put that line there. So your 2 intervals that are bad for business are right here. So while you can whip up the graph without a calculator, honestly, trying to solve this algebraically is a bit of a chore. I know you guys would not want to do that. You totally have to do a little bit of work there. So graphing calculator in conjunction with using your brain, it's always good. All right, next example, we have the height of a yo-yo. All right, so this one has a coast curve as well. Let's see, we want to figure out the minimum and maximum heights. We want to know how much time does it take for the yo-yo to return to the maximum height. All right, so no graph here, just a little bit of algebra. All right, remember when we determined the min and max, the range, right, last week? We would find the ordinary A value, right, our amplitude, and then we would add our shift in. So this 1.75 tells me my max would ordinarily be 1.75, and my min would be negative 1.75. But I have a shift of 2.25. So I'm going to add 2.25 here, as well as down here, which tells me my height, the maximum, that's going to give me a 4. The minimum is going to give me a 0.5 or a half. Now that makes sense because, you know, your yo-yo is not going to bust through the ground. Okay, so that height has to be positive. So negative 1.75 is not a real world value. All right, next question. What they're asking for you is how much time does it take for the yo-yo to return to its maximum height? All right, what they're asking for is how long it takes to complete a cycle, right? So we have a coast curve, right? And our coast curve would look something like this, right? Start high, and then it would go to the low, and it would go back up to the high. That's one complete cycle. So they're asking you in a fancier way how to find the period. All right, so we want to find the period. Now, we know that the period is 2 pi over b. All right, our b value, let's scan. Our b value is right here. It's a pi. 2 pi over pi gives me 2. We're talking about time in seconds, so it takes 2 seconds for one cycle of the yo-yo to complete. Okay, so again, real world problem. Little corny. I don't know if anyone who does the yo-yo anymore, but it is very relevant to a sine or cosine curve. Okay. All right, next one. Example 3, we have a Ferris wheel. It's constructed such that a person goes on the wheel at its lowest point. That makes sense, right? We wouldn't climb all the way up to the top of a Ferris wheel to get on. Now, this Ferris wheel is 5 feet above the ground, reaches its highest point at 130 feet above the ground. All right, the amount of time it takes to complete one full rotation, so one full rotation is AKA the period, is equal to 8 minutes. All right, a person's vertical position. So if you track the height, not necessarily, you know, it goes in a circle, the Ferris wheel, but if you track the height the person is going at different points on that rotation, you can actually model a sine or a cosine curve. Here, we're going to model a cosine curve, and it's going to make sense when you talk about the graph. So we're going to sketch this. We're not going to use a calculator. We're going to use our brains. Now, to sketch a curve, you do need to find A, B, and C. So take a sec. Let's try to figure out what our A, B, and C values are. All right, so A, right, we're going to get from using our max minus the min over 2. All right, so let's see. It's the highest point is 130 feet. The lowest point is 5. So 130 minus 5 over 2 tells me my A value is 62.5. Okay. Our C value is the next easiest piece to find. That's going to be our midline. Max plus min over 2, right? And that's 130 plus 5 over 2, which is 67.5. Okay, let's find the B value. So we get that from the period formula. So 2 pi over B is equal to, let's see what it said. It takes 8 minutes to make a full rotation. So we're going to set that equal to 8 over 1. Cross multiply, 8B is equal to 2 pi. All right, so we're going to divide by 8, and then we're going to reduce. B equals pi over 4. All right, so that's all our interesting information, writing the equation. So your equation, we'll get back to that. Let's first talk about what's going on here. We know that we have a low point of 5. We have a high point of 130. All right, we know that it takes 8 minutes to make a full rotation. We want to sketch one cycle. So we space by the period, which is 8, divided by 4, which means every increment, I'm going to go up by 2's, all the way up to 8. So 2, 4, 6, 8, right? We have 4 slashes for one cycle going up in increments of 2. Makes sense because the period's 8, so I should finish up here one rotation. All right, now to help us graph, We know we have our midline. That midline is right here at 67.5. Okay, so we're going to sketch this. Now, this is where it's important, right? We get on at the low point. We're not getting on up here. Traditional coast curves start up here, but they can start at the minimum. So we're going to do that. We get on time 0. We get on the Ferris wheel, right? And then remember with the coast curve, we go up to our midline. And now we're going to get up to our max, right? Halfway around, I'm up at my max, back down to my midline, back down to my min value. Now, the reason why I started down here, right? They said you get on the bottom. So here's the representation of the path of that Ferris wheel. Now, writing up the equation, this is really important. You have a y equals. Now, our A here is positive, 62.5, but we know we sketched a negative coast curve. So you have to make sure that you take into account it's a negative coast curve. So a negative here, A value is 62.5. Cosine, our B value is pi over 4 times T plus our C value of 67.5. So that wasn't too bad. We were able to use our brains to set up the graph, made sense, and then we made an equation out of it. Okay? All right, almost done, loves, almost done. All right, good. Nice multiple choice question. All right, so let's see what we have here. We have example 4, possible hours of daylight in a given day is a function of the day of the year. In Poughkeepsie, New York, the minimum hours of daylight occurring on the winter solstice is equal to 9 hours, and the maximum hours of daylight occurring on the summer solstice is equal to 15 hours. All right, so that makes sense, like guys, right? The shortest days in the winter, the longest days in the summer. We're actually coming upon when we're going to have the longest day, right? Because June is upon us. All right, so they tell us the shortest amount of daylight is going to be 9 hours in the winter, and the longest is going to be 15 hours in the summer. All right, if the hours of daylight can be modeled using a sinusoidal equation, what would be the equation's amplitude? All right, the amplitude comes from the max and the min, right? Our A value, right? So we have our equation, A equals max minus the min over 2. So the most sunlight we're going to get is 15. Take away the shortest amount of sunlight would be a 9. All over 2. That's 6 over 2 means our A value is 3. Now, if we were going to graph this, it could be a 3 or a negative 3, right? Depending on the context of the problem. All right. Example 5. I like this problem a lot. A little corny. It's kind of cool. It moves quick, so you won't be tortured. We don't have to graph it. But it says a student attaches one end of a rope to a wall at a fixed point 3 feet above the ground. All right, so you're standing, you attach one side, right? You don't have a partner, you're by yourself. You attach the one end of the rope 3 feet up, okay? Now what you do is you grab the other end and you shake it up and down. So kind of like those ropes at the gym, right? They make a sine curve. I don't know if you ever saw that, the 2 ropes, they kind of work your shoulders. All right, so let's see what we have here. That person is shaking that rope and they're making a sine curve. They tell you a couple of things. They tell you the range of the rope's height above the ground is between 1 and 5 feet. So the highest it's going to go is 5 feet. The lowest it's going to go is 1 foot. The period of the wave is 4 pi. They want you to write the equation. All right, so anytime they ask you to write the equation, you need your 3 basic things. You need A, you need B, and you need C, right? A, B, C. Okay, so let's kind of attack it. To get A, right, we have that formula, max minus the min over 2. All right, so they told us it goes as high as 5. Take away our low value of 1 over 2. That's 4 over 2, which is 2. So my A value done. All right, B value I'm going to come back to. The C value I'm going to jump into because it's pretty much the same as this, but it's max plus the min over 2. So now 5 plus 1 over 2 is 6 over 2 is 3. So I have a 3 here. All right, oh no, not there. Whoopsie, 3 here. All right, my B value. To get my B value, this is what most people forget. You have to take your period formula, 2 pi over B. You set it equal to the period that they give you. The period is 4 pi. So we're going to set it equal to 4 pi over 1, cross multiply. So 2 pi equals 4 pi times B. Remember, we want to solve for B, so we divide by 4 pi. That cancels that. 2 over 4 gives me 1/2. So my B value is 1/2. So now we just got to write up the equation. Look at the format of the equation. Y equals A sine BX plus C. All right, our formula. Y equals our A value of 2. We have sine. Our B value of 1/2. Make sure you put the X in there. And then plus your C value of 3. So a couple of things, right? Think about the picture. That 3, right, represents your midline. That's where you actually attach the rope to the wall. Also, right, think about it this way. If you started your graph without the shift in there, right, you would go to a height of 2, right, and a minimum of -2. But remember, it's a sine curve. Sine always starts at 0. So if there was no +3 here, that rope would be on the ground. But we wanted it to go up 3, which means we had to shift up 3. So when you get to pre-calc and talk about vertical shifts, again, you would understand in 2 different ways. Either C is the midline, so you knew 3 was the midline, or you can interpret it as the shift up from the sine curve's usual starting point. All right, so that's the scoop. Enjoy your day. Do the homework that's attached to it. Make sure you know how to graph a sine curve. Make sure you know how to write the formula. So any questions at all, just reach out. All right, bye guys.